all the prefix information. Next, moving on to the options field. The options field in router LSA, network LSA, inter-area router LSA, and link LSA is expanded to 24 bits to support the OSPF v3 version. Then the link state ID. So particularly this value in the inter-area prefix LSA and the inter-area router LSA, autonomous system external LSA is used to identify the particular link state database. And then all the addresses and router IDs are also represented by the link state ID in OSPF v2. And then the link state ID in the network LSA and link LSAs is always the interface ID of the originating router. And for this reason only, the network LSAs and link LSAs are now the only LSAs whose size cannot be limited. We cannot limit the size. A network LSA must list all the routers connected to the link, and the link LSA should link all the address prefixes of the routers on the link. So these are the details about the LSA types. Then moving on to the next one, which is NBMA in OSPF. Particularly the NBMA, which is non-broadcast multicast access network. So in such networks, the designated router and the backup router performs the LSA flooding. So LSA flooding, it just sends the information out of an interface directly to the neighbors. And especially these devices that share some common features, they become the neighbors on that particular segment. And this OSPF v3 protocol, it sends a hello packet. So with the help of hello protocol, the hello packets are shared between the neighbors, and the neighbors are been then defined. So when the neighbor sees that their interface value is mentioned in the neighbor's hello packet, then they become active neighbors. So after they become the neighbors, then they can do the exchange of their database values, and this is called as getting or generating the adjacency. First thing is sending hello packet, and second thing is exchanging databases. So after exchanging database, it is called as adjacency is being established. And in the point-to-point and point-to multi-point networks, this flooding, the routing updates happens as a proactive manner to the immediate neighbors, and there is no concept of the designated router or backup router in these. Whereas all the routing information is flooded to every networking device. On the broadcast or NBA segments only, this v3, it minimizes the amount of information to be exchanged on the segment by choosing one router to become the DR and one router to be the BDR. DR means designated router, BDR is backup designated router. So thus the devices on the segment, they have a central point of contact for all the information to be exchanged. And instead of every device sending the routing updates with every other device, each device it only sends the information with the, or it exchanges the information with the DR and the BDR router. Then this DR and BDR that relay the information to the other devices. So that is the concept. And then coming to the DR election. So the software, it takes the priority of the devices on the segment and determines which device will be the DR and BDR. So based on the priority value, this has been chosen. The router with the highest priority is chosen as the DR. And then if sometimes there is a possibility for a tie value, then at that time the router with the higher router ID takes the precedence. So after the deer is chosen, the BDR is also selected in the same way.